Okay. So today what we want to talk about is the derivative of log and exponents. But we actually know one of them already. Do we know any exponential or log derivatives? This one we know. Okay, this one we already know. If you differentiate this, it stays the same. Okay, we already covered this one. Okay, this is an exponential function. It's got a base. But we don't know how to do this one, for example. Right? We don't know this. We don't know this either. And we don't know how to do this either. Ln of x. Okay, this is what we want to find out today. Okay, and mix these functions with product rule, chain rule, and so on. Okay, the first one that I'm going to prove to you how to do, I'm going to show you how to do, is this one. Okay, so 1, right? So what is dy over dx of ln of x? Okay, the answer is 1 over x. Very nice. Ln of x is 1 over x. And here's how you do it. We start from, okay, this is proof, y equals ln of x. Okay, what's the exponential equivalent of this? So hopefully you guys remember the definition of log. Log, right, ax is equal to y means the same thing as this. This is a definition of log. Make sure you can recall that. You know that at this time, right? So this is, do you see that this is going to be x is equal to e to the power of y? Right? Because ln base is e. Okay, when what we do is we differentiate this implicitly. Okay, so what's the derivative of e to the power of y? E to the power of y. But you gotta chain it by dy over dx. The derivative of x is 1. Isolate it. Dy over dx is equal to 1 over e to the power of y. But look, e to the power of y is equal to what? X. That's the proof. Make sense? Do an example of that, okay? So, example 1. Okay, differentiate this, please. A. Let's do ln of, let's say x squared plus x. Okay. B. Y equals the square root of ln of x. Okay, so I assume that everybody's seen ln, but if you haven't seen it, that's what it means. Ln of x is nothing special. It's a log with the base e. Okay. Okay. So the first function on this a is this ln. You gotta take care of that. And it's this 1 over whatever the ln, whatever's inside of the ln. So it's 1 over x squared plus x. And you gotta chain that by x squared plus x. So you get 2x plus 1 over x squared plus x. That's the derivative. For part B, what's the last function that's being applied to x? Is it ln or is it the square root? The square root, right? Square root. So you gotta differentiate that first. So you get this. And then you chain that by the derivative of ln of x, which is going to be 1 over x. So in simple form, you get 2x ln of x.